Hello, I am Abhinav Sharma. Welcome to Python Wife. Now, let us look into some more examples of the recursion. These are some of the popular recursion programs that you will encounter on a daily basis. So, the first is Fibonacci series. So, what is Fibonacci series? It is a series of numbers in which each number is a sum of its two preceding numbers. The sequence starts from 0 and 1. For example, if we need to find the Fibonacci series up to digit 4, so what it would be? So as we said, it starts from 1. So the first digit is 0. Second number in the sequence is 1. The third number will be the sum of its two preceding numbers, which is 0 plus 1. So the third number will be 1. Now what will be the fourth number? Again, the fourth number will be the sum of its two preceding numbers, which is 1 and 1. 1 plus 1 is 2. So this is a simple concept of a Fibonacci series and it proceeds in the same way. So now let us design a base case for our Fibonacci series. What will be the base case? So as I said, series starts from 0 and 1. So the base case will be if Fibonacci series of 0th number is 0 and the Fibonacci series of first number is first 1. So this will be our base condition. Now let us dig more deep into what can be the recursive case. So in the above example, if we need to find the Fibonacci series of fourth number, what we have done is we have find the Fibonacci series of third plus Fibonacci series of second, right? In the similar manner, if we need to find the Fibonacci series of nth element, then it would be n minus 1th element plus Fibonacci series of n minus second element. So this will be our base condition for a Fibonacci series or a recursive condition. What are the unintentional cases here? So the unintentional cases are number n should not be a negative number or a floating point value or a decimal number. Now let us write a code for our Fibonacci series. So let us create a function called fib. It will take an element n up to which we need to find a Fibonacci series. So first let's write our unintentional cases, which says if n is less than 0 or n is not equals to int, then we will return not defined. Similarly, now let us define our base case. It says if n is equals to 0 or n is equals to 1, we will simply return our n, because n of 0 is a 0 and n of 1 is 1. Finally, we will write our recursive call. So recursive call will be Fibonacci series of n minus 1 plus Fibonacci series of n minus 2. So this will be our Fibonacci function. Now let us try to print what will be on the fourth position, right? So for this, let us try to compile our code and let us run this file, and you can see 3 is printed. So what will be on the fourth position? So let us visualize this output. When I write fib of 4, it will go to 0, then 1, then 0 plus 1, 1, 1 plus 1 is 2, and this is the third index what will be the fourth one? The fourth will be 2 plus 1 is 3. So you can see 3 is printed here. Similarly, let's check for the output 5. What will be on the fifth position in the sequence? So for this, let us again run our code in the terminal, and you can see 5 is printed. Again, let's visualize why 5 is printed. So if we do Fibonacci series of 5, what it will call for is 0, then 1, then 0 plus 1, 1, 1 plus 1, 2, 2 plus 1, 3, and the next element will be the fifth element. So the fifth element is 3 plus 2, which is 5. So you can see 5 is printed here. Now let us take another example, which says we need to find the sum of digits of a positive number. So what is this? Sum of digits of positive number. Alright. So what, for example, let's say we have a number called 3214. This is a number. We need to find the sum of all its digit. So sum of its digit will be 3 plus 2 plus 1 plus 4, and it will be 10. Similarly, we have many other numbers, and we need to find the sum of this number, sum of all the digits of that number. This problem can be solved using recursion. Now to obtain each digit separately, we perform some modular operations and some division operations. So now let us visualize how modular and division operations help in solving our purpose. So for example, our number is again 3214. Now what will be the mod of 3214? So we will take mod with 10. So any number mod with 10, what it will give? It will give us the last digit. Why? Because 3214 divided by 10 gives us the remainder 4. Right? And what will be the division value? So when we do 3214 divide by 10, it will return an int value, which is 321. So here you can see that 321 is separated from 4. Hence we have got our value, last unit value, which is on the units place. Alright. This function is then called recursively for remaining digits. So what will be the recursive call? In the second turn, this is the first recursive call. Alright. What will be in the second recursive call? We will again do 321 modulus 10, and what it will return? It will return again 1, and what will be the 321 divided by 10? It will return 32. In the again the third recursive call, we again do 32 modulus 10, and it will return 2, and 32 divided by 10, it will return 3. So here you can see we have separated all these values. Alright. Now let us try to write our recursive call. What will be our recursive function? Alright. So what can be the recursive function? For example, there is a value. Let us create a function called digits, or let's make it more comprehensive, sum digit, and it will take a number. Alright. Now what will be its recursive call? Recursive call will be number modulus of 10. Alright, because this will give us a remainder. And then what we want sum of digit, and this will be recursively going to call num divided by 10. Alright, and what, for how many iterations it will go? It will go up till we get this last execution, until we get this last digit. This will be our base condition. Alright, base condition will be 0. Alright, because when we proceed from here, when we go from 3 divided by 10, it will return 0. So our base condition will be 0. Now let us write the code for this function to better understand this code. For example, let us create a function called definition of some digit, and this will take an argument num. All right, first let us write again our unintentional cases. Unintentional cases, again, if the number is lesser than 0 or number is not an integer, not equal to num, what it will return? It will return not defined. All right, similarly, let us define our base case, which is if num is equals to 0, what it will return? It will return 0. And finally, we will call our recursive function. So the recursive function will be returning some digit num divided by 10, and this will be added to our num modulus of 10. All right, so this is our simple function with the base condition, unintentional case, and a recursive call. Let us try to run this function. So we will start with our same example, which is sum or digit, and 3214 will be our digit. Let us take some more example, and this time let's take some bigger value. All right, and let us try to run this code. Okay, we have commented out the things. Okay, let us now run this file, and here you can see 10 and 30 is printed. So sum of 3214 we have seen earlier is 10, and the sum of digits of 4, 5, 6, 7, 8 is 30. Thank you for watching. For more such videos and detailed explanation, visit pythonwife.com.